So when we're dividing our polynomials by certain factors, we can use the factor theorem that states that if we have a 0, then we know a factor. Right, so on the previous example that we just did on the other video, what we looked at is a question where I gave you a 0 and then you were able to factor it and divide by those. But what happens if we don't have a 0? What if we don't already know where a 0 exists? So what if we don't know basically an x-intercept of our function? So this is where there's a really nice theorem called the Rational Zero Theorem. So really the types of zeros that we're most comfortable working with, these are going to be rational numbers. So things like, say, 5 is a rational number, say -2 is a rational number, 3/2 is a rational number, say 9/3 or -4/3. These are all rational numbers. So these are the types of zeros that we like. So this is a really nice theorem for us to use. So let's see what this says. So if a polynomial, say f of x, has any rational zeros. So remember, these are going to be things that are like fractions. So any whole number is a fraction over 1. Obviously, fractions like 1/3, those are obviously rational numbers. So if it has any of these, then the 0 must be of the form this. So x is going to be some rational number, p over q. Now, what these, the top and the bottom, come from, the numerator, these are going to be factors of our constant term. So constant terms, these are going to be the ones that have, say, no powers of x connected with it. So that'd be something like this case would be a -3. That'd be our constant term. The denominator, these are going to be factors of our leading coefficient. So remember, the leading coefficient, this is the coefficient of the highest power of x when everything's multiplied and expanded all together. Okay, so we're going to look to figure out what are the factors of the constant term, what are the factors of the leading coefficient, and we're going to form a whole bunch of fractions, and these are the only possible rational zeros. Now notice, this is not saying that our function has these as zeros. It says we're going to make a list of possible rational zeros. Then we're going to verify to see are any of these the case. There's plenty of functions that have no rational zeros. Maybe the only zeros are going to be plus or minus the square root of 2. Right? We can have those, but this is saying that if they do exist, they have to be of this form. And these are the nice ones that we'd be looking for anyways. So let's take a look at how do we apply the rational zero theorem for two different examples. So here, so we'd like to make a list of all possible rational zeros of this function. So to do this, we need to figure out what are the factors of our constant term. So we're going to look at the factors of the constant. So our constant is -3. So we're going to list all of the factors of -3. So these are going to be whole numbers that divide -3, actually integers that divide -3. So we know, for instance, 1 is going to divide 3, right? But also -1 divides this. So we have plus or minus 1. Both +1 and -1 divide -3. Also, with the same idea, both plus and minus -3. These are both, all of these are the 4 factors of our constant. Now, similarly, we can do the same thing with our leading coefficient. Leading coefficient in this case is 5, because that's the coefficient of the highest power of x. So our factors of the leading coefficient, these are going to be plus or minus 1, and then obviously plus or minus 5. Now, there's no other factors. 2 doesn't divide 5, for instance, so this is it. So what we're now going to do is we're going to make a list. So we have our possible rational zeros. So we're going to form fractions now where the top number are going to be the factors of our constant and the bottom number is going to be the factor of the leading coefficient. So we're going to have this long list appear. So we see on the top, we have the choices of either the constant term is going to be plus or minus 1. And on the bottom, our leading coefficient, the factors of this is going to be plus or minus 1. But when we're dealing with plus or minuses, we know that, for instance, a positive divided by a positive is a positive, positive divided by negative is negative, and all those things. So really, we don't have to worry about all of these cases. Some of them are duplicates, so we are just simply going to simplify this to plus or minus 1, because we know 1 divided by 1 is just 1. So similarly, if now we look at other factors of our constant term, we have plus or minus 3 divided by plus or minus 1. So this was plus or minus 1 divided by plus or minus 1, plus or minus 3 divided by plus or minus 1. But again, we can just simplify 3 over 1 as 3, and the plus or minuses can just be combined to just plus or minus 3. Now, we've done all of these on the top with the denominator of plus or minus 1. We're going to repeat this with the 5. So with this, we'll have plus or minus 1 divided by plus or minus 5. But again, remember, we don't care about the plus or minuses. And so they all just combine into a single plus minus 1/5. And then the last one will be plus or minus 3 over 5. So if this polynomial has any rational zeros, they must be one of these 8, right? 2 choices here, 2 choices there, 2 choices there, 2 choices there. So this is it. So that's what the rational zero theorem states. This is the list of all possible rational zeros. So this one over here, now we're going to look at all possible rational zeros of this polynomial. So again, we're going to look at factors of each of these. So we're going to look at factors of the constant. So factors of our constant term, we see there's a whole lot in this case. Negative 36. So there's a lot of numbers that are going to divide 36. So obviously the negative, just plus or minuses, no matter what. So even if this was a positive 36, it would still be plus or minus numbers. So we know, for instance, plus or minus 1. That will always be the case. No matter what our constant term is, it will always be plus or minus 1. Similarly, 2 also divides it, so plus or minus 2. 3 divides 36 because of 3 times 12, so we have plus or minus 3. 4 divides that because 4 times 9 is 36, so we have plus or minus 4. Now we have plus or minus 6, we have plus or minus 9, plus or minus 12, plus or minus 18, and plus or minus 36. So the factors of our constant is there's a whole lot of them, right? So in this case, it was just plus or minus 1, plus or minus 3. So now we look at the factors of the leading coefficient. So now if we look at our leading coefficient, which is 1 in this case, the only factors of 1 are plus or minus 1. So that's it, just simply plus or minus 1. So now we're going to form fractions where the top number up here, these are going to be factors of our constant term. So these are this, and we're dividing by plus or minus 1. But if you divide, say, positive 1 by positive 1, you get 1. You divide negative 1 by positive 1, you get negative 1. You do this by negative 1, you just flip the signs. But they still have the 2 choices of plus or minus. And so that's the case with all of these. Anytime you divide these by plus or minus 1, you still get plus or minus the same thing. So in this case, my possible rational zeros, in this case, this is just my whole list from up here because we're just dividing them by plus or minus 1. So it's just simply plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, plus or minus 36. And so that's what it looks like to apply our rational zero theorem. And then the next step that we're going to take a look at is to figure out which one of these are zeros, right? It's just a list of possible zeros, but which one of them actually are zeros, if any of them.